Section 7.5 has to do with more formulas, and here we have sum and difference formulas for sine and cosine. And the reason we would need to use something like this is if we look at these angles that we have here, 75 degrees, 15 degrees, pi over 12, these are angle measures that are not necessarily on the unit circle. So we can use a combination of two different angles, and if we can find two angles on the unit circle, we can use these formulas to try and help us determine the sine and cosine of those angles. All right, so first of all, we want to find two angles on the unit circle, so I'm just going to make a note of that. Find two angles on the unit circle whose sum or difference is one of these numbers. All right, so if I'm looking at cosine of 75, two angles that can either add or subtract to be 75, how about cosine of 45 plus 30? Both of those angles are on the unit circle. So by using the sum of cosine formula, we are going to calculate those values. All right, so here we have the sum, we're going to add these together, and the difference, if I'm subtracting, notice I have cosine, cosine, and then sine, sine. If I'm adding, I'm going to change the sign. Okay, so if I have cosine of A plus B, I have cosine of A times cosine of B, and then subtract cosine of A times sine of B. All right, so same thing here. If I'm subtracting my two angles, I'm finding the cosine of each angle and adding that to the sine of each angle. When we get to the sine of the sum of or difference of two angles, it's a little bit different. We'll talk about that in a minute. But here I have cosine of two angles. So let's say this is 45 is angle A and 30 is angle B. So I want to find cosine of 45 times cosine of 30. And because I'm adding here, I'm going to subtract. And I'm going to run out of room here. But I'm going to have sine of 45 and sine of 30. Let's see if I can keep that inside so I have enough room for all three of these. All right, so we're going to either have to reference our unit circle, or we can, with angles in the first quadrant, we can use our hands. But cosine of 45, 45 is square root of 2 over 2 for both sine and cosine. So this is square root of 2 over 2. And I'm going to put that over here as well, square root of 2 over 2. Now 30, and I'm going to zoom out here. 30, if I remember the hand, this is 0, 30, 45, 60, 90. So 30, if I bring this finger in, I have one number less. So that would be the sine. So the sine of 30 is 1, square root of 1 over 2. And the cosine would be the 3 fingers up here. So I have the square root of 3 over 2. So this is the square root of 3 over 2, and sine of 30 is 1/2. Okay, so I'm going to multiply those together and then subtract them. So here I have the square root of 2 times the square root of 3 is the square root of 6 over 2. And I have the square root of, sorry, that's over 4. Then I have the square root of 2 times 1 is the square root of 2, and that's over 4. So I could put this as one fraction, 4 on the denominator, and square root of 6 minus square root of 2. Okay, so that is it. In part B, we have cosine of 15 degrees. So I want to try and find two angles on the unit circle that gives me 15 degrees as their sum of difference. So if I think about this, these two angles here added up to 75, but if I subtract them, I'm going to have 15 degrees. So this would be one where I'm doing cosine of 45 minus 30. And this would be our alpha A and B here. So this time I have the same values here for cosine of 45 and cosine of 30, except for I'm going to add them in between. So cosine 45, cosine 30, and then I'm going to add sine 45, sine 30. All right, so I can use these same values over here. Cosine and sine of 45, square root of 3 or square root of 2 over 2. Cosine of 30, we said over here was square root of 3 over 2. And sine of 30 is 1/2. So this becomes the square root of 6 over 4 minus the square root of 2 over 4, or square root of 6 minus square root of 2, all of that over 4. All right, so it's easier for us to do this when our angles are in measures of degrees, because if I go to radian measure, we're looking at fractions, and we're going to probably need to get a common denominator. So thinking about this, if I want to end up, this is 1 pi over 12. So technically that's half of pi over 6. All right, so half of pi over 6 is pi over 12. And we won't have a formula for halfsies until the next lesson. So if I'm thinking about two numbers, I'm going to subtract them to get 1 pi over 12. And common denominator, and if I think about it, I can get 4 pi minus 3 pi is 1 pi. So 4 pi over 12 minus 3 pi over 12 is 1 pi over 12. Okay, but technically if I reduce this, this is pi over 3 minus pi over 4. And that would give me pi over 12. All right, so I'm going to have cosine of pi over 3 minus pi over 4. So if I use my formula, I'm subtracting, so I'm going to go up here. So I have cosine pi over 3, cosine pi over 4, minus sine pi over 3, sine pi over 4. Just barely fit it in there. All right, so it might be easier for us on the unit circle to think in terms of degrees. So pi over 3 is 60 degrees, and pi over 4 is 45 degrees. Okay, so if I'm thinking of 60 degrees, this is 60 degrees here. Cosine is going to be the square root of 3 over 2. And cosine of pi over 4, that's a 45 degree angle, square root of 2 over 2. And I'm subtracting here, so I'm going to change my sign. So pi over 3, 60 degrees, my sine is square root of 3 over 2. Whoops. I'm sorry, I did cosine of pi over 3 should be 1/2. I should be looking this way for cosine. So this is 1 over square root of 4 or 1 over 2. And this way would be sine. So this is 1/2 here. And sine is square root of 3 over 2 times square root of 2 over 2. And this is basically what we have over here. 1 times the square root of 2 is square root of 2 over 2 over 4, sorry, plus square root of 6 over 4. So this is 2 square root of 2 plus square root of 6 over 4. All right, so now we're going to look at the sines of these. Okay, so if I have angles A and B and I'm adding them up to be a different angle, we can use the formulas. Now notice here I have a sine and a cosine in each part. Sine of A on the left side, sine of B on the right, cosine, cosine, they're split, but the sines stay the same. All right, I will give you these formulas. You do not have to memorize them, but just kind of pointing out the differences here. So if I'm finding the exact value of sine of 7 pi over 12, okay, so thinking about what I did up here, if I'm subtracting these and I get 1 pi, I can add these same angles and get 7 pi. So this is the same thing as sine of pi over 3 plus pi over 4. All right, so here I'm going to do sine of the first one and cosine of the second. So I have sine pi over 3, cosine pi over 4, and then I'm going to keep the sine. Then I'm going to have cosine pi over 3 and sine pi over 4. All right, so going back to our unit circle, pi over 3 is 60 degrees. Okay, so I put down one finger, and sine would be square root of 3 over 2. Pi over 4 is 45 degrees, so that's square root of 2 over 2. And then I'm going to add cosine of pi over 3 is going to be 1/2. It's the opposite or the other side of those fingers. And sine of pi over 4 is square root of 2 over 2. So this is square root of 6 over 4 plus square root of 2 over 4, which gives us the same thing. All right, so then we have sine of 165. And thinking about that, this is going to be an angle in quadrant 2. Okay. There's lots of ways we can get to 165. We can probably do some subtraction or addition, but let's try sine of 135 plus 30. Both of these are on the unit circle. So I have the sum of two angles, so I'm going to use the same formula as I just did. So this would be sine 135 cosine 30. And then I'm going to keep the same sign, so I'm adding cosine 135 sine 30. All right, so sine of 135, and I thought I had a unit circle handy, and I can bring it in here. So 135 is right here. this would have sine and cosine as negative square root of 2 over 2. It's negative for cosine because it's in the second quadrant. Sine is positive square root of 2 over 2. So for that 135 angle, I'm going to have square root of 2 over 2 for sine and negative square root of 2 over 2 for cosine. Now cosine of 30, here's my 30-degree angle. Let's zoom back out here. 30-degree angle, I have sine is 1/2 and cosine is the square root of 3 over 2. Okay, cosine is the square root of 3 over 2 and sine is 1/2. All right, so we'll combine these. I'm adding them. Multiply the 2, so I get square root of 6 over 4. Add, and this would be negative square root of 2 over 4. So this is actually a subtraction problem. Square root of 6 minus square root of 2 over 4. And then I have 75 degrees. And here, if I do 75, this is another addition because I can do 30 plus 45. Is there another way? 90 and 15. I could probably do some bigger angles, but I'm going to stick with addition here, 30 and 45. So this would be sine 30 plus 45, or 45 plus 30. It doesn't matter which order they go. All right, so the same process. Sine of 30, cosine 45. And then I'm adding cosine 30, sine 45. All right, we should be getting better at this. So sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. (45) is square root of 2 over 2 for both sine and cosine. So this is the square root of 2 over 4 plus the square root of 6 over 4, square root of 2 plus square root of 6 over 4. All right, so all of these, we've pretty much used the same values for the same angles. Okay. Moving on to the back. Here it says to find the exact value of the expression where we have sine 80 cosine 20 minus cosine 80 sine 20. Well, if I think about it, this kind of looks like the difference between two sine angles. All right, so this is sine of A plus B, and our alpha or A is 80 and my B is 20. So sine of 80. And then are we adding or subtracting? With sine, we keep the same sign. Oops, I'm getting ahead of myself. So 80 minus 20 is the same as sine of 60. And 60 degrees, the sine is square root of 3 over 2. All right, that one was pretty easy. Example 4 gets a little more difficult. Here it says we have sine of an angle alpha is 4/5. That angle is in between pi over 2 and pi. So this actually is in quadrant 2. Okay, between pi over 2 and pi. Then we have another angle on another unit circle, and it has a sine of -2 over square root of 5. And this can be found between pi and 3 pi over 2. So this is in quadrant 3. Now, what we want to do is let's draw out those triangles. Okay, so this is just defining what quadrant it is. This is our domain. All right, so if I were to make my 2 unit circles here, the first one is in quadrant 2, so I'm going to draw it this way. Whoops, that was crooked. So this is alpha, or our angle A, and we know the sine of that angle is opposite over hypotenuse, so the side opposite is 4, the hypotenuse is 5, and down here, if we remember some Pythagorean triples, 3 squared plus 4 squared is 5 squared. So this side is 3, but it's in the negative direction. All right, so if I wanted to find cosine of that angle, I'm going to have the side adjacent, which is -3 over the hypotenuse. So the cosine of that angle is -3/5. Then it says cosine of angle B. So if I were to label angle B, we said it was in quadrant 3, so it's going to be down here. And it says sine is -2 over square root of 5. Well, in quadrant 3, sine is negative, tangent is the only one that's positive. So we have to find this side. So I'm going to have -2 squared plus y squared equals square root of 5 squared. So this is 4 plus y squared equals 5. Y squared is 1. So I have a 1 here, but we have to be careful because this is going down, so it's negative. So in this case, cosine of angle B, here's my angle. Cosine is adjacent over hypotenuse. And I actually labeled this wrong. Sine is opposite over hypotenuse, so this should be -2, and this one should be -1. Okay, opposite over hypotenuse, here's adjacent and hypotenuse, so this is -1 over square root of 5. And we will rationalize the denominator later on. It might be easier to just leave it this way. All right, so in part C, it's asking us to find cosine of alpha plus beta. So cosine of 2 angles added together. So we're going to use our cosine, sum of cosine formula. So I'm going to do cosine of A, cosine of B, switch the sign, and then I'm going to do sine of A and sine of B. All right, so going back up to our problem. So our sines are up here and our cosines are down here. All right, so cosine of A. So here's angle A. Cosine is -3/5. Cosine of B is -1 over square root of 5. Then I have minus sine of A is 4/5, and sine of B is -2 over square root of 5. All right, so here we have, and it might be easier now just to change this to square root of 5 over 5. It might be easier to do that for both of these. So this is -1 square root of 5 times -3, so this is +3 square root of 5 over 5 times 5 is 25. and then I'm subtracting, and this is 4 times -2 times the square root of 5, so this is -8 square root of 5 over 5 times 5 is 25, so this is actually plus here. So I have 3 plus 8 is 11 square roots of 5. Remember, I can add the coefficients and keep the same common denominator, 25. All right, here's another one, sine of a plus b. Same thing, except for we're going to use the sine formula, which is sine of a cosine of b, change or keep the same sign, and I have cosine of a sine of b. So sine of a is 4/5, cosine of b is negative square root of 5 over 5 if I rationalize the denominator. Cosine of a is negative 3/5, and sine of b is negative 2 square root of 5 over 5. Okay, so I just rationalize that denominator. So this is negative 4 square root of 5 over 25. And then plus 3 times 2 is 6, and that becomes positive 6 times the square root of 5 over 25. So now I can combine these. Negative 4 plus 6 is 2 square root of 5 over 25. And the very last part asks us to establish an identity. And while we're working on those, recently we can't pass up a chance to do a little bit of practicing here. But we have cosine of a minus b over sine a sine b equals cotangent a cotangent b plus 1. All right, so this is what we want to end up with. So we'll work on the left side, and because we have the difference of cosine, we should probably use that formula. So I have cosine of a cosine of b minus sine of a sine of b, and these are opposite signs, sorry. On the denominator, I'm just going to keep sine a and sine b. All right, so when I just have factors on the denominator, I can actually split this up into 2 parts. All right, so I can take cosine a cosine b over sine a sine b, and then I have plus sine a sine b over sine a sine b. All right, so this side, these are just the same. So these cancel, and I have plus 1 right here. And if I look at these 2 parts here, I have cosine over sine, which is cotangent of A, and then I have cosine over sine, which is cotangent of B. So this gives me cotangent A, cotangent, oops, not cosine, cotangent of B plus 1. So this is what I wanted to get.